All right, guys, so this is the first of 5 videos that I'm recording. And this first video is just a framework to kind of give you some perspective on what the next 4 videos are going to hold, which are all examples of graph sketching. So the reason I thought that this would be an appropriate place to make videos, originally my thought was if we have class on Friday, we could flip the classroom and you guys would have a chance to do homework in class and whatnot, and then Beaverton canceled school. So now instead what we're going to do is we're just going to go ahead and use this so we don't continually get more and more behind, which will make it easier in terms of finishing up those projects. I mean, you're going to have a project and a take-home test and a final, like, all in succession, and I want to give you time to assimilate this information. So that's why I'm taking the time to do this, even though we now no longer have school on Friday. So this is the full table that I will use. We've talked about this in class. Notice that I added this extra line right here with the shape. That's going to give you a place to sketch out the shape of the graph based on f prime and f double prime process, whether it's concave up and concave down, and that has to do with this table that we did in class some point in the last couple weeks. So that was presented earlier, but if you want to recopy it just for your notes to have a complete section, that's totally up to you and your organization. I have added 2 other things here, right there and right there. Now we've talked about this. It's positive, negative infinity if it's open, if you're on an open interval. However, if you are on a closed interval, the second example I have is closed, you would just put the endpoints there, but it gives you a place to give that end behavior for the graph. And we're also going to take some time to locate asymptotes on this and put the asymptotes in this meat of the table so we can process especially concavity around these asymptotes. Increasing, decreasing, and concavity can change on either side of an asymptote, so we need to consider those asymptotes as both CPs and POIs in terms of checking for changes in concavity and increasing versus decreasing. Okay, so this is the structure I'm going to use. I also want to give you a general process by how you can approach these. This is not a firm process like, oh, if you don't do this first, you're in trouble, that you're not going to know how to do it well. That's not the case. You can do these out of order. But this is, if you want kind of an algorithm of how to process it every single time, this would be a good way to go about it. Step 1, we talked about it. Step 1, I always think, and we laughed, like, why, of course you think. Well, I think about domain and range. I think about what I already know about the shape of the graph. Sometimes it's a graph that I'm going to know something about, and I'm going to articulate that. Oh, it's a sine cosine. I bet you there's some kind of curves happening to it. Oh, it's a polynomial. I know what polynomials look like. Oh, it's a rational function. I wonder if there's an asymptote happening there. Okay, I wonder if there's an asymptote. And now with those asymptotes from the last class, we have this idea that we can figure out the limit as x is approaching positive, negative infinity. And I'm sorry, I have the world's worst stylus, of f of x to see if there's a limit or if it's positive, negative infinity, because if there's a limit, then that indicates that there is a horizontal asymptote. Okay, and then we also know that the limit as x approaches some c value of f of x will give us positive, negative infinity, and that indicates that there's a vertical asymptote. So I think about all those things now before I even think about CPs, because I want to include particularly these vertical asymptotes. I'm going to include those on the table, my understanding of them. So I think about all those things with the graph before I even think about anything else in terms of critical points. I just want to get a framework for what's even happening on this function. So then I find all the CPs, the POIs, the increasing intervals, the decreasing variables, the concave up and the concave down, and I get a perspective for all of those graphs. Incidentally, one thing I didn't put on the previous, I can't roll back, but one thing I would think of on the previous with thinking, that's where I'd also put the zeros. If they're easy to find, I would think about any x-intercepts or y-intercepts. It just gives me another anchor place to put them down, but it's not required. And okay, so the third thing, this is where I think about the shape of the graph and what's happening at all those specific values. And then once I've got all of that down, that's when I graph it. And so that's the framework that I'm going to use in the remaining 4 examples.